Supposed to name the congruent sides and angles for each pair of congruent triangles. So it may help if you draw it. You don't have to though. The congruent sides and angles. So that there's three sides, there's three angles. There's going to be six things that you need to write. The angles are the easiest to do. A comes first, H comes first. So angle A and angle H are congruent. Same with angle D and angle K. G comes last, L comes last. That's the angle. So now for the sides. It takes two letters to name a side. So AD comes first, and it is the same as HK because they are also first. DG is second, and it's going to be the same as KL, which is also second. And then GA is going to be the same as LH. Think of it as wrapping back around. Yeah. Huh. You put what? It doesn't matter. It does. No, the order doesn't matter. Yeah, Mary.
So we can draw it like label the points. Okay.
Yeah, if you were to draw this, we would pick a triangle like this, and I would call it ADG. And I would draw another triangle, and I'd try to make it look the same as it, as much as I could, and that's about that. And then I would just make sure that these letters, so if H is at the top, if A was at the top, I'm going to put H there, I'm going to put K this way and L that way. So that would be a drawing of those two, if I wanted to do that. And that is 16. And the other one was 20. Name all of the small triangles in the figure are congruent. Name 3 larger congruent triangles. Oh, okay. So if you look at it in the book, there's a big triangle. It's made out of little ones. We want to name 3 larger ones. Oh, take a look at UFS. You see U, F, and S? That makes a bigger triangle. So does TDV. It makes a bigger triangle that's the same size as UFS. And then I see ACB. ACB also makes a bigger triangle. So that's all it wanted you to do was name 3 bigger triangles that are the same size, same shape. More on congruent triangles. So we learned how to name them with the vertices being labeled in the right order, and we learned how to name the congruent parts, the 6 congruent parts. And the whole reason that we're getting into that is one big requirement of geometry is that you can prove 2 triangles are congruent. And this is where it actually starts. So I'm going to start with drawing a triangle. Okay. Here's a triangle with 3 sides of different length. And I want you to think just for a second about taking those sides apart, like if that was made out of toothpicks of different lengths, and rearranging those so that you could make a triangle that has different angles. Do you think it could be possible? If it had to be those side lengths. If you can't change the side lengths, do you think you can make a different triangle? Really? That would be the same triangle, it would just be rotated. Yeah, with different angles completely. Do you think you could do it? I don't either, Shanique. I don't either. Because here's the problem. If I were to move these sides, because that's what you'd have to do to make different angles. Like if I were to move this one in a little bit, I would have to shorten this side to still make it be a triangle. If I move it away, there's going to be a gap. And if I leave it alone and I move this in, then they're just going to cross over. So if I know that two triangles have the same side lengths, I really can't draw equal triangles, but you have to take my word for that. Then I know that the two triangles have to be equal. And that is called side, side, side. And here's how this works. In a very simple, let me use the same drawing. Let me just put some A, B, and C, and D, E, and F. Given that drawing, prove the triangle ABC is congruent to triangle DEF. This is a very simple one. More simple than probably what you're going to end up with. But I don't want to do all that hard work. I'll leave that for you. Okay, so remember these. On the left you have your statements, on the right you have your reasons. Okay, well if everything in the diagram is given, then I can say, hey, AB is the same as DE. And BC is the same as EF. And you know what? AC is the same as DF. Why can I say that? Given in the drawing. To use side, side, side as a reason and a proof, you have to first state three pieces of evidence, because this is kind of like it's on trial for it being congruent, and you're proving that. So you have to state all the evidence, and AB is congruent to DE, BC is congruent to EF, AC is congruent to DF. Once you've stated that you have three pairs of congruent sides, then you can say these two triangles must be congruent because side, side, side. Won't find many more proofs easier than that. How do you what, Mary? Three congruent pairs of sides. Side, there's a pair of sides. Side, there's a pair of sides. Side, there's a pair of sides.
So since there's three sides that have equal on each triangle, then it says it.
Right. This is short for, are you ready? This is what SSS stands for. If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So if all three sides of this one are the same length as all three sides of this one, you've got the same triangle. But instead of writing all those words, we're just going to write SSS. All right, Anasha?
Okay, if you had, you know how you have 3, 2, 1 on the first one, ABC?
Yeah, okay.
Okay, what if over there, it's right, where EF is the 9?
Uh-huh.
What if you have 2 instead of 1? And it's not equal, what would it be?
If you didn't have three pairs of equal sides, then you wouldn't be able to prove that they were congruent.
So it has to be equal.
You wouldn't be able to do it. Yeah.
Alright.
Yeah, it does.
Or, gotcha.
Okay. Good, because I got another one for you.